Welcome back. So for this part of this tutorial, we'll be teaching you how we are going to increase our story height and also how to load our structures. Okay, so we come to our story, right click on your story, come to your edit story. So our story height is going to be 3200. What we are going to be using, so we are going to be 3200 story height. Press enter. So for our foundation depth, we're going to be using a 1200 foundation depth. Okay, you can click on OK, and you see on your story you have it 3200 and the story 2 is about 6400 at the final stop. Okay, so you come back to your plan view, come to story 1 on your plan view, make sure it's on your story 1, and we are going to load our beams. So what you do to load your beams, okay, before you load your beams, I usually like to arrange my beams in order. So I come to my review, come to relabel members. I want to relabel the members. So I come to relabel members. I want to relabel my columns. I want to also relabel my beams, and also I want to relabel my axis. So column, beam, slab, and axis. So for my axis, so to sort it for column slabs, I want it to label it from the left top to right bottom. Okay, so the left top will start. It's going to start the first beam by the left corner is going to be 1. The next one after is going to be beam 2. The next one is going to be beam 3, just like that. Same for walls and beams. Alright. So for axis, I want my direction 1. Then my direction 2 to be A, B, C, D, and I want my direction 1 to be 1, 2, 3, 4. Okay, so you can just click on OK and allow it relabel your members for you. So you realize that this is the first beam on top here. You see, if you zoom out, this is the first beam. This area here, this is your first line of beams for a section. So this is your beam 1. The next one is your beam 2. The next one you have is your beam 3, and on the same line, next one you have is your beam 4. It has arranged your beams properly. It has arranged your beams in order. Same thing with your slab. Alright, same thing with your slab. Realize that this is your first slab, slab 1. You have your slab. So it has labeled these members for you, even your columns. You check, this is your column 1, this is your column 2, column 3. Next one you have your column 4 and all of that. Okay, and also for your axis, it has relabeled your axis. You have the first one A, next one is B, C, D, E, F, G, H, I, J, K, L, and so we have all of that. And also for this direction we have the same thing, 1, 2, 3, 4, 5, 6, and everything has been relabeled to perfection. And so you check your 3D view to check that. Come back to your plan view. In your plan view, we want to load our beams. Want to load your beams. So what you do is you click on the beams, right click on it. You come to edit loads. Come to edit loads. Okay, it's wall load you want to add. Okay, sorry, I've cancelled that mistakenly. So you can click that again. Okay, so you can click that again, right click on it, edit loads, wall loads. Alright, so you can see this on our wall loads. So wall unit weight, the unit weight of a block is about 2.40, 2.47. Okay, but then we are going to be adding finishing and finishes, yes, plastering and all of that. So we can just make this 3.40 just to make provisions for the plastering and whatever finishing we want to use, if it's paint, if it's for tiles and all of that. So what's the height of our wall? Remember we used a 450, we used a 300 beam, so the height of our wall is going to be a 3200 minus 300 depth of beam that we use for our roof. So that's going to be about 2.9, so 2900. Our block is 225, so we change this to 225. Okay, so once you do that, just click on this. This is the beam, so you just click on it and your wall load has been added. Okay, it has the magnitude, so the magnitude of that is like 9.86. Okay, so you can click OK. So just to see what you've done, you can come to your 3D view again and rotate about that axis, and this is it. You've loaded, this is our wall load. Okay, you've loaded that way. So you can come back to our plan view and we will look at that again. So you can copy this because we need to add wall loads. So you can copy this, copy loads. We want only the wall load, so you can click OK. I've copied that. So we click on the beam we want to add. It there. We want to hold your control key. You want to add it here. You want to add it here. You want to add it here. You want to add it here, and you want to add it here. You can control V. Alright, so to select multiple items, what you do is you click. When you click on the first member, you hold your control key. You're going to see plus or minus. By that, your cursor. Then you click on the next member, and it will select multiple members. Hold your control key while you select. You hold your control key while you select. Then you press Control V, and it's done that. So you can go back to 3D view. Okay, so this is what we have. So we're going to be loading other members. So we don't have a load here. We have a load here. Okay, we have one here. We have one here. We have here. So pretty much it. So you just look at where you have your wall loads and you add your wall loads. Okay, so you Control V. Alright, so we have your wall loads. Okay, so we won't have wall loads on this beam because remember, on our first floor there is no wall there. Our walls are at the edges of this slab. They are the edges of this slab. So what we're going to do, we are going to add a line load there, which is going to act like a wall load. So we are going to be adding line loads there. So you come back to your plan view, you come to loading, and you come to point, line, and area load. This is the point load, this is a line load. So we click on line load. The magnitude we are going to have is going to be a magnitude of 9.86. Remember, 9.86, that's the magnitude of our wall load. Okay, so you click on the areas you want the wall load to come. So it's going to be like this. The wall load there, there's another one here. There's another one here. So we have another one from here to here. I have one from here to here. One from here to here. Same thing here. We have one from here to here. And one from here to here. Okay. That is for this area. Do same for this other area. We have one from here to here. I have one from here to here. Also from here, from here to here. I have another line load from here to here. I have one from here to here. And from here to here. Don't forget this other one inside here. You can press your escape. Okay, no, I think we don't have one here, so we delete this one. We delete this one. We don't have that one there. We have it 9.86. So we have it here and not there. Okay, I think we have it here. We also have it here. There's a wall here. Alright, so my bad. We have a wall here too. We have a wall here too. So come back to your 3D view. Just look at it. You notice, yeah, we have added it. This is the area we have our load. So that's the wall load we're adding there. Okay, so we have successfully added all loads to that building. And for the story one, next thing we are going to check is we are going to also check it for our story 2. So we come to, still on the plan view, click on story 2. So you can copy the beam, copy, you're going to edit loads. So just at the same way, load wall. Since we don't have walls on the roof, so we are going to just mimic what is there. So we are going to use a height of 1,000. Okay, height of 1,000. And this is the unit weight, so we just insert it. Okay, so it's 3.40, so you can just click OK. Same thing, just copy loads, wall load. Okay, so you can just click from beam 2 to hold your shift key, and so you can select all the beams, then Ctrl V to paste it. So we can just go back to our 3D view and we have loaded our structures. Okay, we have loaded our structure. That's how it looks like. Okay, so you can save your work, just so you don't lose any information. You can save your work. So after loading, the next thing we're going to do is we're going to analyze. We come to analysis, you come to your load decomposition by fixed end. You select for it to do it both together, then you calculate your slab loads. So since there is no slab on your second story, there's no load decomposition on your second story, so you click OK while it decomposes the load on the first story. Click on OK. Okay, so it's done. Click close, and you notice that there's a green tick here. It means that it has done the analysis. No, it has done the load decomposition from the slab to the beams and from the beams to the columns and all of that. Okay, so after that is done, the next thing you need to check, which is probably very important, is for us to come to our building analysis. Okay, we'll come to our materials. Let's edit our materials very importantly. Come to edit materials. Come to edit materials. I'm going to pick a particular concrete. So I'm going to come here. You want to design to 20 to, we're going to do 20 to 25. So apply to all members. So we are going to apply to all, then we click OK. So we are going to be designing to grade 2025. To Eurocode, remember that we designed to cylindrical, not cubes, we designed to cylinders, strength of cylinder, which is 20. Okay, so for steel grade, you are going to be using steel grade of 410. So you apply that to all and you click OK. Same for our foundation floor. Designing to 20, 25, apply to all members, OK. This 410, OK. Same thing, 410. Click on OK. So you can also come here again. So you're going to come to rebar diameter, click on the rebars. Right, so if you hover your mouse over some of these things, you'd notice that this is for columns, this is for wall, this is for beams, this is for slab, this is for rib slab, this is for foundation, footing. Okay, so for our columns, we are going to be using Y12 and Y16. For our walls, we are going to be using Y12, but since there's no wall, we might not need to select or deselect this. We have columns, we have beams. So we have what reinforcement do we need for our beams? I need reinforcement of Y16 for my beams, so I'm going to pick Y16 for beams. For my slab, I need to see if Y10, but let's use Y12 for our slabs. Y12. It deselect every other reinforcement diameters. This is the label, this is the diameter of it. We don't have rib slab, so we don't need that. We come to foundation. Foundation, I need just Y12 for my foundations. Okay, so for my links, I want you to check for Y8 and Y10 for my links. If Y8 passes for links, it goes. If it doesn't pass, then we can increase it to Y10. So that is it. You have selected the particular reinforcement you need for the design of your members, of your structural members. So you can click OK and click OK and click OK. Alright, so that's it. The next thing you need to come, you have to come to your analysis. You can do your building model check again. So you can start for your building model check. Okay, so there are two errors. What is it saying? It's saying that slab this IS21 and IS22 okay, so column 30 and 33, you can just check that. So column 30, 32, column 30 and 33. So we have column this 33, this 33, and this is it should be column 30. Okay, so it's just saying that it's overlapping. Meanwhile, that what it means that it's on a slab. What it means that it's on a slab. When it says overlapping, that means it's on the slab. Usually Prota would want you to place your columns on your beams, but this can also work. This can also work. We are going to check that to be sure. So with that, we don't have a problem. We can come back to our design, come back to analysis, building analysis, come back to analysis, then we are going to do our building analysis. Okay, so we are going to design, we are going to analyze our column, we are going to analyze our beams. You look at this area, you're going to see reselect bars to design. We're not going to reselect bars. Let's just see what, if the minimum is going to pass, nominal is going to pass. We're going to do build analysis. And you wait for it. So it says that these columns, we have column 30, 31, 34, 36, 38, 39, all of this. Is that the members listed above are fully unsupported or supported by beams or slabs. These are the columns we placed on the cantilever slabs. As I said earlier, ProtaStructure advises that you place your columns on a beam. Doesn't advise you place on a slab, but then you can still place your column on a slab, but you must make sure you design for punching shear to be able to check. Okay, so this is just the error message is giving you to tell you that these columns are on a slab and not on a beam. You can just click OK. And it says, warning, problems encountered in the building model. Do you want to continue the building analysis process? Yes, because we are aware of what the error message is telling us about. We are aware of it, so we're going to say yes. And we wait for it to analyze our building for us. Okay, so it has done that. It has analyzed, analysis completed. Okay, so you can just scroll through this and just see what it did. And okay, so that's it. And very, very importantly, after it has done your analysis, the first thing you check is your axial load comparison report. You can click on your axial load comparison report and check. Okay, so for this, I've made a YouTube video on this channel that really talks about this, but just to say it again, what the code allows, your code allows for just 5% change. For example, these are the total loads based on slab loads. These are the total loads decomposed to beams. So the beams from the slab, this is the load on the slab alone, and this is the one that are being decomposed from the slabs to the beams. Okay, so what this means is that we have for added load, for instance, we have a total of about 4,023.4, and also now for our total load decomposed to beams, we have 4,023.4. If you had a deviation on this to about 5,000 thereabouts, that means there's a problem with your model, so you need to check that again. But since they are the same, it means that we are good to go. So if you want to change this, you want to convert this, you can just click here and it's going to export to PDF. We can close this, and you just close. That means we have analyzed our building. We have been able to analyze our buildings on this. Just check our model again. We have been able to analyze our buildings. So we are done with the analysis. The next phase after the analysis is for us to design our members. It's for us to design our members. So the first thing we are going to design our slab. So we come to plan. We don't have slab on our second floor. We have it on our first floor. You click on the story 1. We have your slabs. So to design slabs on ProtaStructure, we use what we call slab strips. So you come to your modeling, come to slab strips. Okay, so it gives you the direction you want. We are going to be using analytical strips. So whatever we analyzed on this video when we did our load decomposition, it's going to use those results to design this as slab for us. Okay, so these are boundary conditions. I made a video when we are doing about design of slab on this YouTube channel. You can just check our playlist where you can find what these end conditions mean. Okay, so but for our boundary conditions, we're going to be having, so we're going to put slab strips. We're going to be starting from this end to this other end. So from this end, the boundary condition is a cantilever, so we're going to pick this. And to this other end, the boundary condition is also a cantilever, so we're going to pick cantilever to cantilever. Okay, so you can click this. And to make your line straight, make sure you hold your control key to make your line straight. So you click on designs. Okay, so you notice that it has provided reinforcement. What is provided is providing Y12 at 250 spacing. So Y12 at 250 spacing passed. So we have done strips for this slab, we've done it for this slab, we've done for this slab, but we haven't done for this slab. So to put slab strip for this slab, we just come to end conditions, beam to beam. Click here, hold your control to make it shift like I said earlier. You click in designs for that slab. Same thing, you hold it. You click on designs for that slab. Okay, so we're also going to be drawing for this slab panel. So it's going to be from this to here. So you can just click here and hold your control key and click the end while it provides for that. Okay, so click here for this other one and click here, and also click for this. We can just click from cantilever to cantilever. Let me just show you something. For example, you did not pick end conditions. You know, this end condition here is a cantilever, as I said earlier. This is a cantilever here, and this other end condition is a cantilever. Let's just assume I picked it from a beam to a beam and see what ProtaStructure will do. So I click here to the end. See what ProtaStructure does. You see that it doesn't design this cantilever slab because I did not, my boundary condition, I picked a beam. So it starts from where I have a beam to design, and also it ends at where I stopped. My boundary condition was a beam, so it also ends at a beam. But if I change this, the first condition was a cantilever and the end condition was a cantilever, and I click update, this is what it does. You see, it now designs this cantilever. You see now it has provided reinforcement for this cantilever. That's why your boundary conditions when you're designing all these things are very, very important. Remember, your software is garbage in, garbage out. Whatever it tells you to do is what it does, and it analyzes based on what it does. The only time it gives you error messages is only when it's something that it thinks you shouldn't do. I mean, it gives you error messages, but still, if you still insist, it either designs for you the way you want to design for you, or it crashes. Okay, so we haven't designed this particular slab. So what we're going to do now, we have our end conditions of beam to a cantilever. So we click here, hold your and click, so it designs that. See, provided that. So you also have the same thing here, hold your control to a cantilever. Okay, so we have successfully added strips to horizontal strips to all the slabs. Okay, same thing, we are going to do the same thing for vertical members. Notice, you see this direction, I put direction X here, so X is horizontal. Let's assume I want to still put a slab strip vertically with the same direction of X. So I click on top and I click. You see the one inside, it says a strip direction is closer to the Y direction, that means vertical, but marked as X direction strip. Do you want to set it as Y direction strip? I'll tell it here. So I want to change it. It's the vertical, so it's the Y direction strip. Okay? So you zoom into it. Remember, as I said earlier, see my end condition at start was a beam. So it did not design for the cantilever. It just started from the beam. See this other one too. My end condition was a cantilever, so it designed that cantilever. So what we're going to do is for our end conditions, we're going to just change this to cantilever, update, so it makes provision for reinforcement for that cantilever too for us. So also for this panel, it starts from a cantilever to a beam. Don't know what's happening, so we can just escape that. Click on this, right click, properties again. So let's just, okay, so let's just fix it at this other side. Right click, okay. So for this other side, it's starting from a cantilever to a beam. So cantilever to a beam, cantilever to a beam. So it designs that. Okay, doesn't, depends on what I pressed. Okay, so that is that for a cantilever, because that's not a cantilever, literally that place is not a cantilever slab, so that's why it's acting that way. Here is not a cantilever slab, it's supported on one side, two sides, and three sides, supported on three sides, so that's not a cantilever slab. Okay, so that's not a cantilever slab. Okay, so literally that to pass, but that's not a cantilever slab. That's why it's but to pass you can leave it as a cantilever this thing, but that's not a cantilever slab. Okay, so the next thing we are going to do now is also for this side, end condition is beam to beam, so beam to beam. Also here beam to beam. So we have this is going to be cantilever to beam, cantilever to beam, cantilever to beam, and also here going to be cantilever to beam for our slabs. So now we have, if you zoom in, we have designed our slabs. If you zoom in, you see what it provides. It provides Y12 at 250 for the top reinforcement. Also for the bottom reinforcement, it's providing Y12 at 250. After our slab, the next thing we are going to design is our beam. So we come to design, come to story beams, click on story beams. So we did the analysis, but we did not design it. Alright, so to design this, we can just come to our settings. First of all, you can just come to your settings, just to set certain things so you don't do it twice. Come to parameters. For our floor beam, we want Y16 as I said earlier. So we want for our links, we want Y8, and also the spacing, you can change the spacing. Let's change the spacing to about 200 spacing. 200 spacing. Maximum, a minimum is 100, but a maximum is 200. Alright. So we can change this steel cord length. Let's 11,500 because of what we have in this country. It's possible that it might not have up to 12 meters cut length, but usually it's 12 meters cut length. So we can change this to about 1,500. Can still leave it at that. So we have minimum top rebar spacing at 50. So maximum. So minimum spacing. Okay, so tension rebar, the maximum. Okay, sorry. So minimum bottom spacing, minimum, I want my minimum to be 40. Okay, so we just leave that at 40. So maximum here we want it 40, here we want to have it at 40. Okay, so we can click OK. We have done our settings. So we come to batch design mode, click on select, we select all bars, then we click calculate. Give it time while it designs your beam for you. Okay, so that's it. You can close that and realize that all your beams passed. So to check it, you can just double click on one of it and you realize that this is what it has provided. Provided links Y8 at 200, 2Y16 top and bottom, 2Y top and bottom, and this passes. Alright, and this passes. So we can just play around it. You can just play around to see what passes. You can just see. Okay, so we just increase this to 2. Okay, so that is it. It passes. You can come to your diagrams to check. Click on diagrams. So you realize that V2 is your shear force diagram and M33 is your bending moment diagram. Okay, so for this span, for beam 1, for this span, our maximum bending moment is 23.4. Our maximum hugging moment is about 38, and for this side is also 22. Okay, you can check that manually if you know how to design beams manually. You can check that manually to be sure that what is provided, but usually the system is correct, fairly correct, very correct. although it over designs in some cases, but then it's always very correct as long as what you imputed is correct. So you have your shear force, you can use this to check your shear force, you can end this. And if you want to produce working drawings, you want to produce reports, you can just click here to create a summary report, or you can click here to provide a detailed report, depends on what you want, and you can convert it to a PDF. Alright, so we have checked, we have designed all our beams and it passes. After that, you can just close it here. You come, next thing after your beams is to check your columns. After designing your beams, the next thing for you to check is to check your columns. So you come to columns. Okay. You come to columns, the same thing. You can come to your settings and parameters, just to be sure. Come to settings and parameters. Come to longitudinal bars. Okay, so we want this. If you want to provide white of it, if it passes and all of that, and we come to links. I want my maximum links to be at 200. Okay, and minimum link bar size to be white. So you can click OK. Come to same thing, batch design mode, we select all bars. So you can calculate that and let it reselect all the bars. So you can close. So that is that. That's provided you with reinforcements. Okay, so you can just double click on this. So to see, same way you can come to your diagrams and just check your V2. This is your shear force diagram. M33, this is your bending moment diagram for, and it has designed your columns. You can create a report. Okay, you can just, this is it, you can save this. Okay, so you want to create a report, you can go to report and you design reports, and you check and design for your design reports. Okay, so it's providing Y12. Okay, this needs a lot of Y12. Okay, but I don't want this, so I can just come to my settings. I can just come to settings and parameters, come to my longitudinal bars. I want my minimum to be Y12 and Y16. I don't want Y12 anymore, so I just click on OK. Come to bar select mode, reselect all bars, and I reselect all my bars. Let me use Y16 for all of it. So close, and yes, 4Y16 passes, 4Y16, 4Y16. For the circular columns, providing 6Y16. So that's it. So can end it. So we have designed a slab. You can also check that your slab design. Notice everything it passes for this strip. Okay, so we can just delete and reselect all bars. Okay, so it's saying strip this 15 and 16. Let's check which strip is that. That doesn't pass, so we just check it. Strip 15. Okay, this and this. So okay, I think because it's small, its span is small, so we can just delete this because the span is small and it's our landing. You can just delete that. Okay. All right. So we have done for our slabs, we have done for our beams, we have done for our columns. So next member in the order, the load from the slab goes to the beam. From the beam it goes to the columns, and from the columns it goes to the foundation. So the next we are going to be designing is going to be our foundations. So you come to, still on the plan view, come to your story 0. Okay, once you come to your story 0, you just click on the one of it, click on one, right click. No, before that, just escape that. Before that, let's come to our settings, because we did not set for our soil bearing capacity. So you just come to your settings, come to your foundations, come to general. So our bearing capacity is going to be 150. Okay, so concrete cover, I want my concrete cover to be 50. You can leave it at 0. It's going to provide minimum that the code requires. I don't need top bars, I need Y12 as my reinforcement. Okay, so we can just click OK. Well, I click on one, right click on it, insert pad footings. So it has designed, you see it has designed, and it's providing 1 2 by 1000. Can cancel this, come back to select, let me come back to settings. Alright, so I want my minimum pad footing to be 1200, please. 1200. My minimum pad depth, I want it at 300. It's 300. Okay, so see the same, right click, pad footing. Okay, so 12 by 12, 12 by 12. So you click OK, and that designs 12 by 12. Okay, 1200 by 1200. Okay, so subsequently I can just select all my columns and right click, let it design it together. So design pad footings for all of it. Done as setting, so you can just say redesign all of it, redesign, and give it time while it designs your pad footing members properly. So it has designed this, and you can see column 1 is 12 by 12. We have column type, we have a type 12 by 12, we have another, we have a 13 by 13 column also, we have a 14 by 14, and yes, that's it. I don't think we have a 15 column, do we? I don't think so. So the highest we have is 13, so you can just click OK, and that has been provided. Okay, so usually it's not nice to have your pad bases like this overlapping each other. So what we can do, we can just delete this, and we're going to combine that footing. Okay, I'm going to combine it. So you just select both of them, right click, and you click insert combined pad footing. So you just click on insert combined pad footings, allow it to design your members for you. So it's saying a 12 by 18 would work, so you just click OK. So it's going to provide 12 by 18. So same thing here, you select it, right click, insert combined pad footings, 12 by 182. So just click OK, and that is that. We are done designing. So we can come back to our 3D view to check that. Come back to your review design status. So you just click on it, click on design status, right? So that's it. Notice on the key here, it says that the red means fail, the yellow is warning, yes, orange is expired analysis, OK is green, did not design is blue, do not design, yes, as not designed is white. Okay, so you notice all our members are green, even as slabs. We run slab strips on all of it, so that's why it's green. That means it passes. All our slabs passed, all of it passed. I told you earlier, even this one that the slab strip was being very funny, see, it passes, so it's green, it passes, and our pad also passes. All right, and please, just to stress, remember what we did, a pad, a combined footing, it's not advisable for your pad bases to interlock, to overlap themselves. So if it overlaps, you just delete it and create a combined pad footing, please, and create a combined pad footing. Okay, so that is it for design. So we have been able to analyze our building, we have been able to design our members, our beams, our columns, our slabs, and our pad footings. So the next thing and the final thing we are going to do is to, you can save this. Next thing we are going to do is to export this. Okay, before we export this drawing, please, I said earlier, we have a column that has been placed on a slab. So you need to check for punching shear. You need to check for punching shear. It's very, very important. So what you can do is you click on the particular column you want to check for punching shear. You can click on this first of all. So you can come here, find punching check, click on punching check. So check column perimeter, include loads within punching perimeter, and all of that. So our column location is not at the center of our building, it's not by the side, but it's at the corner. So we just click this, it's at the corner. These are column locations at the corner. So this is the slab reinforcement that has been provided. You know, it was provided white over 250. You can design check. So you realize that it passes for punching. It passes for punching. That means we can place that column on that slab and it doesn't punch and we are safe. So we can just end that. Okay, we are safe. Okay, same thing with this, we can also check that too, and we can check that for all of it and make sure we are safe. Okay, check that for all of it. Also click this one, right click on it, punching check at the corner, and with design, same thing, it's adequate for all of it, so we are safe. Okay, so we have checked all of that. The next thing we do is to come to our design. We've done that, drawings and reports. Come to Prota details, so we can create drawings for this. So do you want to save your drawing? You want to save it? Yes, so we save. We save that and it's give it time while it loads our Prota details. Okay, so we are going to be auto, once it's done loading, you see auto generate, going to be auto generate, and we just leave everything, just leave it the way it is. All right, click on draw. Just click on any left, click on any place on the sheet and give it time while it produces working drawings for the detailing. Okay, so you just give it time while, okay, so I think it's done. So you check this, you realize that you find your beam details, you have all your beam details, you have your pad footing details, you have what else? Also you have your bar bending schedule for your beams. This is bar bending schedule for your beams. Okay, bar bending schedule for your beams. Let's just say we have this. So this is 1, 2y16 1, the bar mark is 1, so you can just come in to show. Once you come on your bar bending schedule, you see 1. See, so this is the length, is about 7,640 length with bulbs of 380. So in case, you can give this to your iron bender while he works with this to cut your reinforcement for your beam. So that's why it's okay. This is your bar bending schedule. Also, you have your column sections. Alright, this is it, 4y16. You have the other one for your circular columns. Okay, and you have your form plans with corresponding bar bending schedule. This is bar bending schedule for your slab and all of that. This is bar bending schedule 2 for your street 2 for your, yes, for your columns, links and all of that. Okay, also these links and all of that too. So it comes with corresponding bar bending schedules. This is for your slab. This is a bar bending schedule for your slab. Alright, so you have bar mark 25. You can just come here, bar mark 25, and this is it. Okay, so it's literally everything. So you can just come to export DWG file, right click on it and export this to AutoCAD. Okay, so it has exported to AutoCAD. You can just double click on that to see your drawing. Okay, so you continue opening the WG file and that's it. Give it time while it loads. It's still loading. So it's generating model. Okay, so we can just expand this, and this is what we have on AutoCAD. You have foundation GA, we have slab detailing, and we have everything we need to have. Okay, so that's it. You have been able to export your details back to AutoCAD. So that is it on these tutorials. And at the end of this tutorial, we have been able to show you how to make a GA on AutoCAD. Then you import that GA to ProtaStructure, model with that GA, and also design, analyze and design our members, and also export details back to AutoCAD. I hope you've learned. If you have, please don't forget to subscribe to this channel, and subsequently we'll be dropping other YouTube tutorial videos that will help you design structural elements on ProtaStructure, both reinforced concrete design and also steel design, even design of retaining walls and concrete drains and everything, even design of swimming pool and staircases. Alright, so that's it. And please drop a like and also drop comments if this video has helped you in any way. Thank you, and we'll see you on the next tutorials.